Hello everyone, welcome back to another video on concurrent assertions, and this time we are going to talk about consecutive repetition. So without any further delay, let's begin with a simple example. So my very first example says that if A is true, then B is true for the next three clock cycles, and then C is true at the next clock cycle. So here you can see there's a pattern that B will be true for the next three clock cycles. So there is a continuous repetition of B being asserted for three clock cycles in a row. So for such kind of pattern, consecutive repetition just minimizes the the sequence. So let's begin. So I will begin with my let's just write sequence for this particular assertion. You could do the same inside the property. Still, I'm writing the sequence. And let's name this sequence say A, B, B3, B3, C, S, which indicates sequence. So we will begin with our pattern. The pattern is very simple. If A is true, then on the next clock cycle, from the next clock cycle, B should be true for at least three clock cycles. So not for at least for three clock cycles, for exact three clock cycles. So to do that, you just have to write B, and then inside the bracket, you just have to write star and 3. So this is very similar what we can see inside the uh, inside the functional coverage. So inside the functional coverage cover block, you could see such things. So by writing that, you are assuring that the assertion will check that after A is asserted, then B should be asserted for the next three clock cycles in a row. And what does our question says? Then C is true at the next clock cycle. Then it is very simple. You just have to give clock cycle delay C. So this completes our sequence, and this is the format of consecutive repetition side concurrent assertion. So after that, let's begin with our property, and we want our property to get sampled at the positive edge of the clock. So let's write the same thing, B, S, and then instead of S, I will write P, which indicates the property. And I want this sequence to get sampled at every posage of clock. And let's assume that our clock, the name of the clock signal is CLK. And we will simply write the name of the sequence. And now finalize this assertion by writing the assert property statement. And I will label this assertion with the same name, but instead of P, I will use A, which indicates it's it's a label for assertion, for an assertion. Then assert property, and here I will mention the property, else I will generate an error. And Let's just write failed and the sequence is not detected. You can write whatever you want. So this concludes consecutive repetition, and using this uh, you could write a sequence which will detect for multiple repetitions of a single signal. So let's move on to another example and another usage of consecutive repetition. So our next question says that if A is true, then B could the B should or whatever you want to do, B should be true either for 2 clock cycles or 3 clock cycles or 4 clock cycles. And then right after that, C is true. So here there's a difference. Yours This question is saying that B could be true either for 2 clock cycles or 3 clock cycles or 4 clock cycles. So we don't have a single fixed range. Instead, we have three fixed range. And if any three of these ranges uh, pass, then the assertion passes. So this is also another example of consecutive repetition, but with a slight change. So I will begin with my sequence. Let's name this B 2, 3, 4, then C and S. So here inside this, the first thing is going to be same. The A is asserted. Then on the following clock cycles, B could be true either for 2 clock cycles or 3 clock cycles or 4 clock cycles. Otherwise, the assertion fails. So it could be done simply by writing the star and then writing a range. It is very simple. It is very similar to the previous example in my previous video, in which I was just writing the range, which basically indicates that B could be true either at the second clock cycle or the third clock cycle or the 4 clock cycle. But when you use the star, which indicates that you are using the consecutive repetition, then it changes the meaning. Then it says that the range is about the number of times the B could be repeated. So it could be repeated for 2 times, or for 3 times, or for 4 times. If either three of this repetition is detected, then the assertion passes. So after that, C is true, which is same. So let's begin with our property. I would write P, get the property, and I want this sequence to get sampled at the posage of clock. And let's write the name of the sequence. And let's finalize this assertion by writing the concurrent assertion statement. And remember, as I have repeated in my previous videos, that the only difference between concurrent assertion on the way you write the concurrent assertion and immediate assertion is that concurrent assertion, you write assert property and then you mention the sequence or the property. But in an immediate assertion, you don't write property. So let's write the name of the property. So assert property, if it fails, it will throw an error. And we are going to write the same. Let's add some exclamation just for fun. So that was all about the consecutive repetition in which you could just repeat a certain signal for certain clock cycles, and you could mention it like this, inside the square bracket, and using the star. And you could also mention a range in which it will get repeated for either of the values which are mentioned inside the range, and it is inclusive of the lower range and the upper range. So it could get repeated for 2 times, or either for 3 times or 4 times. So that was another simple video on concurrent assertions. I hope you find this video useful. Please stay tuned for more. Thank you so much.